show that the ratio of the sum of the first n terms of the GP to the sum of the terms from n plus first to 2n term is 1 by r to the power of n. So first thing first, what is that we need to prove? So it's a weird thing. So we have the sum of first n terms to sum of n plus 1th term to 2nth term is 1 by r to the power of n. I'll just mention it, where s dash is sum of, no, let me not write that, sum of terms from n plus first to 2nth term. 2nth, that's good enough. Okay, so how can we start off this answer with? So we'll start the proof with, let's consider the geometric progressions. First term to be a and common ratio to be r. Then we have Sn formula that we will make use of. So we have Sn is equal to a into r to the power of n minus 1 divided by r minus 1, right? So that's the sum of first n terms. That's clear. This is the sum of, this is sum of first n terms. Now we are looking at getting the expression for s dash, right? So first is, let's write terms of n plus 1th to 2nth term, right? So how will that look like? We have a into r to the power of n, okay? Then we have a into r to the power of n plus 1, then so on and so forth till a into r to the power of 2n minus 1, right? How is that we got this? Because an, that is any term, is given by a into r to the power of n minus 1. That's why I'm subtracting 1 over here. So n plus 1 minus 1 will be n, is it not? And the last term is 2n minus 1. Okay, in total there will be n terms again over here. So let me make that clear. So with all of this in mind, and that we have the first term to be a into r to the power of n. Then we have the common ratio is r itself because it's the same GP. The number of terms is where you might get confused. So let me change the color. The number of terms will be n. I'll give the explanation over here just for your understanding. This is not required for your exam. See, if I want to count from say 10th term to 15th term, so how will we generally do this? Actually, let me write it in some other way. First, let me explain this 15th term. 10th to 15th, how many terms are there? Well, it is 15 minus 10 plus 1. So that will be 5. Sorry, 6, my bad. So see, 10th is part of it. 10th, 11th, 12th, 13th, 14th, 15th. You can count it. There are 6 terms. So how do you generally count? 15 minus 10 plus 1. So coming back to this, it would be 2n, that's the last position. You subtract the first value's position and add 1 to this. So when we solve it, 2n minus 1 will be n, minus 1 plus 1, so this will be basically n. Okay, again take a simple example, you will understand. Remember, we are starting with 2nth term. So this is the last value. This is the first value's position, to be honest, right? And adding 1 to this entire set of this entire thing will give us the total number of terms in this sequence. For example, if I want to add from 10th to 15th term, how many terms are there? 6 terms are there, right? You can count, literally count 10, 11, 12, 13, 14, 15. You can count it. There's 6 terms. How will you get it? Subtract 15 and 10, add 1 to that. That will be the number of terms. See, the reason being, whenever we subtract 10, the 10 value is taken away. It's like you're counting from 10, excluding 10. So 15 minus 10 will be a count from 11 till 15. But if I want to include the 10th term, then I need to add 1. Okay, with that in mind, with the first term and the number of terms in mind, and the common ratio being r itself, with all of this in mind, we can write s dash to be, just a second, so we can write s dash to be a into r to the power of n, right? So that would be the first term into r to the power of n minus 1 divided by r minus 1. Okay, and at last we have 1 and 2. So we have Sn divided by S dash, which is equal to a into r to the power of n, r to the power of n minus 1 divided by r minus 1. This entire thing divided with a into r to the power of n minus 1 divided by r minus 1. So this a and a gets cancelled. R to the power of n minus 1, r to the power of n minus 1 gets cancelled. R minus 1 will get cancelled. Therefore, Sn by S dash is equal to, oh, I wrote the other way around, sorry. It should have been the other way around. So it is a into r to the power of a into r to the power of n minus 1 divided by r minus 1. This entire thing divided by a into r to the power of n, r to the power of n minus 1, r minus 1, closing the bracket. And we have a getting cancelled, this expression getting cancelled, this and this getting cancelled. And we have 1 by r to the power of n. So that would be your answer. Okay, and that's nothing but your RHS, and we have the proof, right? So the only tricky part over here is this, for me though, at least. I think that's where you guys will go wrong, can go wrong. Highest probability is over there. Anything else, please make a note, highlight that once you have written it.